Okay, hello, hi, this is Kati Ahmed with you and welcome to my channel Super Linux. In this video I want to explain to you how in Haskell you find whether a number is a Keith number or not. Okay, by the way, look here, it's Tuesday, January 5th, 2020. Okay, if you're not sure. Okay, 21, sorry. 21. So like around 2 or 3 days ago this is like an exercise was given to me by some other student in Sweden. He's Syrian, and it was very challenging to me, and what made it so interesting is that there's no solution for it in Haskell. What we're gonna do is solve it in Haskell using pure Haskell programming. There will be no monads or things like that, just recursion, normal recursion. Okay, so how the Keith number or how all this algorithm goes is that as follows. Now you have to start with a number at least 10. Okay, it has to be 2 digits at least, but it has to be therefore at least 10. Okay, and the way it works is as such. Okay, as follows. So if you say, for example, let's zoom it so people can see it. So say like I have the number 197. Okay, I can start with a number of 2 digits, but just for clarity I'm gonna use 3 digits. So if you have a number that's something like 197, what you'll have to do is separate it into 3 digits as such. Okay, this is how you get a sequence, the first step in the sequence. Now you sum all those 3, okay, and you get 17. Then the next step is, and how the series will work is that you move from the 1, start with the 9 until the 17, you get the sum, and it will be 33. Then again you get the 7, got 33, get something like, I think 75, sorry, 57. Okay, let's get the calculator. Okay, so 7 plus 17 plus 33. Okay, then again you go with the 17, 33 and 57. Okay, so plus here 33 plus 17, got 107. Okay, then you go again with 33, 75, 107, and so on and so on and so on. Okay, this way. So plus so okay, 197. Now a Keith number, okay, or a number is called a Keith number when you generate this kind of series. Okay, you'll find that number within that series. Okay, you find the number that you input as a starting point, like here you see 197. You'll find it again inside the sequence that we generated. So if you find it here, and it has to be at least 10. Okay, so the way I've solved it is just I depended on Geeks for Geeks Keith number. Okay, here. Okay, so And also this is when you have 3 digits. If you have for example 4 digits, you have to go back by four digits. So if you have something like 1956, you'll have to do it this way: 1 9 5 and 6, and then you sum those up. Okay. Yeah, so it will be, this is 10 and 11 21, so you'll get 21. Okay, and then okay, you take from 21 till 9. Okay, you sum, then you get a new number here, for example let's say C, then you get that number C, and you go with the 5, then you get number D, then you go D plus C plus 21 plus 6, because you're taking the number of digits to go back in the sequence to sum. Okay, and for example you got here, for example, another new number E, okay, which is the sum of D, C, 21 and 6, because you started the number is 1956, which is 4 digits. Okay, so you go back, okay, from the last sum, okay, starting from the last sum by the number of digits of the input number. Okay, so this is here E, you got new number E, which is 21 plus C plus D plus E, and so on. Okay, now okay, but a number is a kth number if you can find it within this sequence. So you have 197 is within that sequence, 12 is not within that sequence, 14 is within that sequence. Okay, 10 is not a kth number, because although it's at least 10, okay, but it's not a kth number. Okay, because you have to take something at least 2 digits, because you need to sum 2 digits, you know, start with summing 2 digits at least. Now the way I did it in Haskell is this way. What's the code? This is it. No, this way. So this function here will give you the digits of the number in a list. Okay, and by the way, here the algorithm is mentioned in here. Okay, in C I had to translate it to Haskell. Okay, so let's go here. Okay, so this is the file is located here, and number.hs. Okay, and stack.js. I will just load the functions. So I'm gonna show you each function what it will do. Okay, so here, so digs, you have digs here in the first function. Digs, for example, 1 2 3 4 5. So they turn it this way into the digits as separate numbers, okay, in a list. Now slice is a function which, for example, I have, for example, slice. Yeah, we want to take a part of a list. Okay, so this is a function. I looked it up from Stack Overflow. So you take, for example, from index 2 till index 5. Okay, and you have this list of characters A, B, C, D, E, F, G, H, I. Okay, so if you use, it will take this part which is in here. Okay, this one. Okay, I'm taking from 2 till 5, from index 2 till index 5. Now, so because why do we need the slice? Because like I told you, if you see here, we'll have to go, for example, here 197. Okay, you got 17. Then you have to start again with the you'll get a new list, okay, which is this one. Then you have to slice it up starting from here to the end. Then you add it up, and you add it up, and you add it up, okay, and you build it up, okay. Now now the appender is a or no, before the appender, you know, because the way you return, you go back is and count the number of digits, okay. So it will be like you're getting digs, and then you get digs count, digits count, sorry, of this one, okay. Maybe I should add this also. This is I don't know why it's not taking it. It's just like so let's see. You're giving it a number, sorry. So directly a number, okay. So if you have this number, you want to take the get the number of digits. It's 5, okay. It will give you the length directly. Anyway, now we have here the key next is that, you know, when you first start with, for example, 197, so when you want to find the next one, this one, 17, which is 197. This is the first one, okay. This one you can easily find it, so that's why we need it. This is your first step in the recursion. So if we have like key next, the next first next, okay, which is key next of 197, for example, as we said. So it would be like this, okay. We got this one, okay. Now the appender, what it will do, okay, we'll take this one, okay, and give it the count of digits, okay, because what we want to do is also generate the next one, 97 and 17, the sum. We got a new one, which is 33. So how we can go to build it and proceed like we did here, 17, then 33, then 75, then 7, etc, 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 okay. So the appender will do this way. I'm gonna take this one, will be an infinite list, by the way. So here, I don't know whether this is important to have or not, but I just kept it just in case. If I have 0, we don't have a 0 like for the count of digits, which you will use to see how much you are going to go backwards to get a new sum, okay. So the old list is the key next of 197, okay. The count is for the 197 is 3, okay, because we have 3 digits. Then if I put it, see, it will take forever. It will go forever. So what I did is, just for example, just to let you see it, take 5, okay, of this list. So you see, and also no, before that, I have to remove this just for you to understand, okay, just for you to understand. I'm gonna show it to you in a better way. So below, okay. So if I use this here, did I save it? No. See, let's reload. Okay. okay, we have to remove take while because this one for now, because this is for explanation. The final answer is in this line. You will see it. Don't worry. Okay. So it will come to you like this. Okay. Let's say, for example, I took 20. Okay. Because there's some kind of repetition we're gonna get rid of. So this is 20. So you see here like 197 and you get the 17. Then you go 9, 7, 17. You'll find them again. 9, 7, 17. Then 33. Then you see here the 7, 17. Okay. So the 7, 17, 33. Okay. So that's why I had to group them into into that way. Okay. Into this way. So if I get back there, this way, and let's reload. Okay, see, now this way I have grouped them as such. So this the sum in each step is going to be the last one in each element, which is a list. Okay, then next I'll use the map last here, as you see, the appender key next digits count, okay, of the number. Then we have the map last. So if I use this like map last of this, okay, so you get the sums here. Okay, this way I filtered out the sum, okay, in each step. Cool. So okay, so we take all the numbers now. Okay, now we have to take all the numbers which are less than or equal to the input number. We have, for example, 197. Okay, yeah, so let's reload. Now if I use keith numbers, okay, all the keith numbers, they have to be less than or equal to that input number. Okay, oh, it was not saved, sorry. For example, 197. Okay, yeah, because we have to get those numbers. Okay, and of course the keith number has to be what, greater than 10. Okay, so the first three numbers are meaningless. Okay, however, those numbers that start with are meaningless already. Okay, so if you omit listing them, it's meaningless. Okay, in the sequence. Cool. Now we can use down the function called isKeith, which is isKeith. If we wanna write it, okay, is keith number. Okay, x equals if x is greater than or equal to 10, and x is okay. Just let me get the type of lm. which is the function. Okay, yeah, so we have to see whether lm x and Keith numbers, okay, of x. So then write true, give true, else false. That's all. This is the Keith number. So if we reload it, okay, oh, correct, just a syntax matter. Now it compiled. Now I can say, for example, is Keith, okay, 197 to give you true. Now 1 2 3 no, 10 no also, okay, it's because not part of the series. So this is it. Now the key to understand how it's done, okay, is by following the way you do Fibonacci, because it's built on the mentality of Fibonacci, or the method of generating Fibonacci as such. So this is your first list, odd list. Then you take it back. So you slice backwards, like we told you. Okay, slice backwards like this. Okay, and then you do the sum of the slice. Okay, then you do the sum of the slice and add it to the list. Okay, to the previous list. Okay. And that's all. Enjoy. Thanks for watching. Bye.